In number 26, the charge is uniformly distributed around a ring of radius r, and the resulting electric field magnitude is measured along the ring's central axis, perpendicular to the plane of the ring. At what distance from the ring center is E maximum? Now, this one's kind of tricky, because you might remember that the electric field is zero if you're right here in the center. And as you get further and further away from the charge, the electric field will approach zero as you approach infinity. And so there is some magical spot between those 2 points where we do end up with a maximum. The trick is how to figure that out. Well, if you've already looked for your notes, you know that the electric field along the central axis from a ring is given by this equation, where Q is the total charge, Z is that vertical distance, and X is the radius of the ring. And again, we have 4 pi epsilon naught in this equation as well. If you go ahead and graph that, you'll end up again with our 0 point here at 0, and it trending towards 0 as you approach infinity. But there is this maximum right here. How in the world do we find it? Well, for those of you who've had a little calculus already, you actually want to find a maximum or minimum you can figure out when the slope is 0. You're like, well, how in the world am I going to figure out when the slope of any graph is equal to 0? Well, the way to do that is to take its derivative with respect to the variable you're trying to do. In this case, it's according to z along that axis. So in this case, we've got z here. I'm plugging in x, the radius of the ring. They gave it to us up here. And then we're solving this one. If you take the derivative with respect to z, and you do have to use the quotient product rule, you'll end up with something that looks like this. And that might intimidate you a bit. Your TI Inspire will actually do this part for you if you need it. And how do we figure out where the slope is 0? Well, that's when the derivative is equal to 0. So we can simply set that thing equal to 0. And it turns out we can divide by q and multiply by 4 pi epsilon naught on both sides to get rid of those. And so we simply end up with this. From here, it's pure algebra. You've just got to manipulate a bit around here to make this work. For that to equal 0, that top part, or the top portion, the numerator, has to equal 0. So if you set this equal to 0, you end up with a fairly nice expression. Squaring that through, dividing by 2, you get z squared is equal to 0.00028. And you'll discover that where the slope is 0 is when z is equal to 0.017 meters, or about 17 centimeters above this. Please notice that they did not give us the amount of charge. It turns out that was irrelevant to the question. Yes, this one required calculus, but it wasn't hideous, although you did have to do product quotient rule was kind of challenging. Hope this helped. Good luck.